Hello and welcome to lesson 5.3 on properties of logarithms. So last lesson I showed you some really quick, simple properties of logarithms. In this lesson we're going to dive into three kind of bigger, more useful, more deeply embedded properties of logarithms. Now before I begin, there are there are some important things that we need to notice about these properties, okay? These properties all need the bases to be the same. Okay, so every property that I'm going to show you in today's lesson is all reliant upon the bases being the same when it relates to logarithms, okay? All right, so that's key. These properties I show you, if you're not dealing with the same bases or like bases, you cannot use these properties. At least the first two properties. The last one's only a single logarithm. Okay. Something else to just ponder for people who want a little more deeper thought is these rules also seem to be very similar to some of the exponent rules that you have learned in the past. There should kind of be some roots to some exponent, very similar. You'll look at it, you'll be like, that feels very much like some exponent rules or something. At least kind of like, that feels very familiar. Could anybody think of why? Oh yeah, well, logarithms or logarithmic functions are just inverse functions of exponential functions. It's just undoing exponents, or maybe not undoing, but it's kind of the backwards of exponential functions. So that's interesting. It'll have some similar rules. So let's dive into these rules or property. I have three of them. Okay, so we'll cover the first property, and most textbooks call this the product property. Product. Kind of C and T are running together. Product property. Now, product means multiply, so you'll probably guess that this has something to do with multiplication. Okay, now the other very important key thing about these properties is that these properties can go either direction, left to right or right to left. So we could use them to put logarithms together or break them apart. But it says if I have a log of base b and I have x times y, I have two things multiplied together. That is the same thing as having log of base b to the x, or input of x, plus log of base b with an input of y. Okay? So this can go either direction. So if I have two separate logs, but both have the same base and they're being added, I can smush them together into a single log where I'm multiplying these. This is very similar to some sort of exponent rule when you have like bases, like 5 to the third times 5 to the 7. We would say that's like 5 to the 3 plus 7. It's like almost the opposite kind of rule, isn't it? Instead of the thing in between them being a multiplication, the thing in between them is an addition. And instead of adding the exponents, we multiply these inputs. So it's very similar to the exponent rules. If that's confusing you, you ignore it. That's just a little bit extra for people who want to dive deeper. But I can go both ways with this. If I have two separate logs and I say I have a big algebraic expression and I like to simplify it and I have two logarithms with the same bases being added, I can smush them into a single log and just multiply those two inputs. Or if I need to figure this out and this is really messy to figure out and I'm trying to just get some sort of value, I can break this back apart if I need to make things easier to handle. I will go ahead and tell you. Sometimes it's useful to put logs together. Sometimes it's useful to pull them apart. And I think that's probably the thing that most students get frustrated about in this chapter. So let's do an example go in either direction. We'll do an example pulling apart and an example putting things together. So let's say I have log base 5 of 3x. This property tells me that I'm allowed to pull this apart into log base 5 of 3 plus log base 5 of x. So this could come in handy in a few different ways, but say I'm trying to just calculate part of this, or I'm trying to isolate x, and I'd like to just kind of subtract that. I could use this in many different ways, but it's a multiplication. I can break it into the same logs with the same bases as an addition. Okay. Another example. Say I would like to simplify, and I have a log base 11 of 2 plus a log base 11 of 3, and I'm like, those are pretty nasty to figure out. I don't know if I want to figure it out yet, but I would love to just smush these together into a single log. Well, they both have the same base, so I can. I can say, well, that's log base 11 of 2 times 3, which would be 6. So I could use it to go either direction. Okay? All right. Next property, the second property. That one was called the product property. This one's called the quotient property. And I'm just going to write prop, because property is a long word to write. It goes like this. It's very similar. Instead of having a multiplication, let's say I have a logarithm of some base, just say b, and I have a division, x divided by y. I'm allowed to say, hey, I could break these apart, log base b of x. Instead of adding, since it's a division, I'm going to have a subtraction, log base b of y. Or if I have two logs with the same bases being subtracted, I could rewrite it as a fractional single log. Now notice that the input that is on top will be the first input subtracted. The second input is the one from the bottom, because order with subtraction does matter. Okay, and I could do this either direction, but let's work a quick example. So for instance, if I gave you like log base, I don't know, 10 of 27 minus log base 10 of 3, you notice they're the same bases. And so I bet I can make this look a lot nicer if I smush them into a single log base 10. And I would say, oh, well, they're being subtracted, so I'm going to divide 27 divided by 3. So I could write that as log base 10 of 27 divided by 3 is 9. So I can make that a lot simpler looking than what I originally started with. I can also always go backwards and pull things apart if need be. Okay. And then finally, the last property. Okay. This is what they call the power property. Power prop. Okay, and it goes like this. And once again, it also can go either direction. So say I have a log base b, and I have some input x. And that input is raised to some exponent. We'll just use an r. You're allowed to rewrite this. This is equivalent to, if I have, I'm going to leave a little bit of space. I need to write something out front in a second. Log base b of x. But instead of having r be an exponent to the input, it can actually come out front as a multiplier or multiple to log base b of x. These two things are equal. And I can go either direction with this. Okay? Well, this is extremely useful sometimes for handling some things. This is probably one of the, all properties are very important, but let's look at an example. So say I have log base 5 of x to the third. I can rewrite that as 3 log base 5 to the x. Okay, so I can pull exponents from the input and put them out front. Okay, so I can do this with a few other things, like just for more excitement. Let's say I have something like log base 4 to the square root of 2, and you're like, oh, that's horribly nasty. Well, remember, radicals are nothing more than fractional exponents. So a square root is nothing more than 2 being raised to the 1/2 power. Well, that's still nasty, but this is an exponent. We can bring it out front. And I can make this look a little nicer. So bring the 1/2 out front, and that's times log base 4 to the 2. Now it's looking better. Still a little nasty with the fraction up front. This is enough to leave it there, but if you wanted to, you could make it even prettier, because that's the same thing as log base 4 to the 2, all divided by 2. But the property, we're just practicing the property, so there's no need to go above and beyond doing that. Okay. Now here's the other thing is, I can mix and match all these properties together to do, well, any bit of moving around that I want to. If I want to smush everything together that I can smush together, I can use it. If I want to separate stuff apart, typically I'm more interested in mushing things together to kind of simplify things. But sometimes in solving or working with things, it's easier to pull things apart. But let's use property to kind of smush everything down as much as possible. Okay, so we'll mix and match a few together. So like log base 2 times log base 5 to the third plus 3 times log base 5 to the 2. Now here's what's interesting about this. I cannot do this. I cannot combine them unless they're the same base, right? I would go ahead and tell you, if you're trying to smush everything together, use the power rule first. So you see I have a 2 out front. Let's go ahead and stick that up top as an exponent. And on this one, it has a 3 out top. Let's stick that one on top as an exponent. And so I'll have log base 5 of 3 squared plus log base 5 of 2 to the third. And I can handle 3 squared and 2 to the third. I know those. Those are not too hard. So I'm not going to change anything else yet. I'm just going to do that. 3 squared is 9. And 2 to the third is 8. Okay, cool. That's pretty good. Now look, they have the same base, so I can smush these together into a single log with the same base. And I'll have 9 times 8 as the input. Okay, well, what's 9 times 8? I believe that's 72. So we can finish with something that's really quite tidy looking. Log base 5 to the 72. Oh my, well that's much nicer than what we started with numbers everywhere. So we can mix and match these rules to kind of make life look a lot simpler. Okay. I can do the division rule, I can do exponent rules, I can also mix and match rules to try to pull things apart if I want to. But it's not that difficult, but they're very useful. Okay, in the next lesson or so, we'll get into kind of some of the usefulness of these as we start working our way through solving some logarithm functions. I guess really in 2 lessons we'll start solving. I have one more thing I want to show you in the next lesson before I jump into solving in the last lesson in this course. Okay. But that's all I have for you, just these 3 simple properties and rearranging logarithms. So practice the homework. If you have any questions, just send me an email. Have fun.